بسم الله الرحمن الرحيم. إني التدريسية الأستاذ المساعد الدكتورة شيلان محمود حمل برزنجي، تدريسية في قسم الهندسة المدنية كلية الهندسة جامعة الانبار، أدرس مادة كورس التصاميم المنشآت الفولاذية لطلبة المرحلة الرابعة. وأقدم لكم هذه مقدمة عن هذا الكورس. Our lectures is an introduction about design of steel structure course by Assistant Prof. Dr. Sheilan Mahmoud Hama, a lecturer in Civil Engineering Department, University of Anbar. First, we look about the outline of this lecture. General, advantage and disadvantage of steel as construction material. Materials, type of structure C-section, cross-section of some of more commonly used hot rod shape, loads, philosophy of design, building code, design specification. General, structural steel is one of the basic material used by structural engineer. Steel as a structural material has expectation strength, stiffness and ductility properties. The widespread use of structural steel make it necessary for structural engineers to be well versed in its properties and uses, following some of requirement concepts that need to be understood. The first requirement concept is statics. Statics mean the ability to compute reactions on basic structure under given loading, the ability to determine stability and determinacy, the ability to determine internal forces and statically determine structure, which is mean develop shear and moment diagrams, the ability to solve a truss problem both in 2-dimension and 3-dimension by using either method of joints or method of sections, the ability to solve mechanics problems, the ability to compute sectional properties including cross-sectional area, moment of inertia for section of homogeneous material, moment of inertia of composite section. The second concept, mechanics, which is mean an understanding of stress and strain concept, the ability to compute stress including axial stress, bending stress, shear stress due to both bending and torsion, principal stress, the ability to compute the buckling capacity of columns, the ability to compute deflection in beams, the ability to compute reaction and internal forces for statically indeterminate structure. Then we should know about properties of material. The ability to read stress-strain diagram to obtain critical material properties, which is including yield stress, ultimate stress, modulus of elasticity, ductility, and understanding of the statical variation of material properties, which is so important to understand the behavior of the material. Another concept which is very necessary to be understood, structural analysis, which means an understanding of the nature of the load on structure, the ability to compute and use influence line, influence diagram, the ability to solve a truss problem, which is include force and deflections, the ability to solve a frame problems, force and deflection, the ability to structural analysis, to use structural analysis software. Structural engineering, which is include design of different structure, building, bridges, dams. Well, in this part, safety is needed. Also, the structure which we design should support its own loads and support and has ability to support external loads. Now, steel design. Steel design, what it means? It means selection of structural form, determination of external load, calculation of stress and deformation, determination of size of individual members. After we look about the concept we should understand it before we begin design of any structure, now we go to discuss the advantage and disadvantage of steel as construction material. We begin with its advantage. which can be concluded by high load resistance, high ductility and toughness, easy control for steel structure, elastic properties, uniformity of properties, addition to existing structure. While disadvantage is the steel structure has no ability to resist the fire, no ability to resist the corrosion. These 2 points lead to high cost, fire and maintenance cost, specifically to buckling, fatigue, and brittle fracture. Materials. The materials used in structural steel can be summarized as structural steel section. For structural steel section here, there are properties and 4 quantities are particularly important for given steel types. We should know the minimum yield stress, Fy, the specified minimum ultimate tensile strength, Fu, the modulus of elasticity of steel, Es, and shear modulus. We can take a look to the figure. This figure is represents stress strain diagram for structural steel. This point 1, 2, 3, 4 is representing proportional limit, elastic limit, upper yield strength, and lower yield strength. Point 1 is the limit between elastic strain and plastic strain. This is a jumping from elastic behavior to the plastic behavior of the steel. Yield strength is so important criteria to the steel structure design and should be specified for any steel structure section. There are several types of steels as following. Carbon steel. Carbon steel can be classified according to carbon percentage content. To low carbon steel, which is carbon content is less than 0.15%. Mild carbon, which carbon content between 0.15% to 0.29%, such as steel A36, A53. Medium carbon steel section, which is the carbon content between 0.3% and 0.59%, like A500 and A529 steel. High carbon steel section with the carbon content between 0.6% and 1.7%, like A570. Another type of concrete is high strength low alloy steels, which have a yield strength Fy 40 KSI to 70 KSI. For example, A572, A618, A913, and A992. This figure is showed typical stress strain curve for different types of structural steel. We can see the carbon steel A63 with Fy 36 KSI, while high end strength alloy carbon steel A572 have Fy 50 KSI. Heat-treated constructional alloy steel A514 have a minimum yield strength Fy 100 KSI. We saw that the steel which is heat-treated is giving a high yielding strength and high strength and giving a high strength steel. Another part which is important in the steel construction is a bolt. Bolts or bolting is a very common method of fastening steel members. Bolting is particularly cost effective in the field. High strength is necessary since most bolts are highly tensioned. In order to create a large clumping force between connecting elements. They also need a lot of bearing and shear strength so as to reduce the number of fasteners needed. The type of bolts are carbon steel bolt A307. These are a common non-structural fastening with a minimum tensile strength Fu of 60 kSi. High strength bolt A325. These are considered as structural bolts with a low carbon. Their ultimate strength could be reached more than 120 kSi. Heat treated structural steel bolt A490. These have carbon content up to 0.5%. They are conditioned and reheated to 900 degrees. The minimum yield strength apply of this bolt range between 115 kSi up to 130 kSi. The ultimate strength for the A490 bolt are 150 kSi. This picture shows the type we mentioned before. The first picture is the bolt 307, which is carbon steel bolt. The second, 849 bolt, heat treated structural steel bolt. The last one, A325, which is high strength bolt. The two last type of bolt are structural bolt, which used to connect two structural steel sections together. Another material which is a part of steel structure design is welding material. Welding material is a process welding. We begin with the definition of the welding. Welding is the process of uniting two metal parts by melting the material at their interface so that they will bond together. A filler material is typically used to join two parts together. Since structural welding is typically done by an electrical arc process, the weld metal is typically supplied via welding rod. This picture we show the shielded metal arc welding process electrode. This is the picture. It shows the welding rod, which is used to uniting two steel structure parts together. The most important part in a steel structure construction is structural steel section. We have many types of structural steel sections. First type is hard rod section. The standard rod shape are shown in the figure. We have wide flange shape was commonly used in construction in steel structure construction, which is denoted or known by W shape, American standard beam or S shape, American standard channel or C shape, L angles, and we have two types of angle, equal length and different length, and denoted or known by L section. Structural T section or W2 or ST. Also we have pipe section, structural tubing, bars and plates. And these represent the standard rolled shapes. Cold form section, as shown in the figure. In cold form section, we have many shapes. Channels, these, shaped double channels, angles, and hot section. Sometimes we can find a steel structure, a steel section with the dimension that required with special dimensions. So we made a built-up section by connecting two or more plates together using bolting method or welding method. The section will called built-up section. Built-up section can take a many form. Built-up section W shape, built-up section C channel, built-up section L angle, and another shape like box section, angle section, double angle section, and so. Now we look about the details of more commonly used hot rod shape. W shape or wide flange shape. For example, W shape can be found in ASTM denoted by, in the code or the manual denoted by W18x50. The first number 18 represents the depth of the section in inch, while the second number represents the section weight in pound per foot. That's the same for S-shape or American standard. For example, S18x70. 18 section depth in inch and 70 represent the section weight in pound per foot. But for L shape or angle shape, we found L 6x6 cross 30/4. The first two numbers represent the leg length. The third number represent the thickness of the section. As we mentioned before, we have two types of angles, equal leg and unequal leg. In unequal leg angle, first number represent the length of the taller or longer leg, while the second represents the shorter length of the leg, and the third is the thickness. For C shape, C 9x70, the first number represents the depth of the channel, while the second represents the weight of the shape. The steel structure designed to have a ability to hold the load subjected to. So we should know the type of loads, the types of loads. So we should look about the load applied on the steel structure. We have dead loads, also known as a gravity load, including the weight of the structure and all fixed and permanent attachments. Live load also belong to gravity load, but their intensity and location may be varied, not permanent load. We have highway load, rail live load, impact load, snow load, wind loads, earthquake load, thermal load, and other loads, for example, rain load, hydrostatic load, and blast load. The loads can be also classified to static load, applied slowly that the structure remains at rest during loading, while dynamic load applied rapidly in very short period of the time to cause the structure to accelerate it as consequences of inertia forces. Now we move to the philosophies of the design. Any design procedure requires confidence of the engineer on the analysis of load effect and the strength of the material. We have two main procedures which adopted by the designer: allowable stress design method and load and resistance factor design method. The first design method, allowable stress design method. Safety in the design is obtained by specifying that the effect of load should reduce stresses, that is a fraction of the yield stress of y, say 1/2. This is equivalent to factor of safety of OS equal to Fy over 0.5 Fy equal to 2. So the factor of safety in allowable stress design is equal to 2. The mathematical description of this method can be as the follow: phi Rn over gamma larger or equal to summation Qi. Rn represent the resistance strength. Phi represent the resistance factor or strength reduction factor. Gamma is the load factor. Phi over gamma factor of safety. Qi applied load. The figure shows the stress strain diagram here for the steel. As we show that in this method, the area from point Fy can be used. The upper part is unused strength. We can take advantage from the ultimate strength of the material. This method is an uneconomical method. So we move to the second method of design, which is more economical and can take advantage of full strength of the steel section, and which be recommended in the steel manual. The method is load and resistance factor method, LRFD. This method is based on strength of material. It considers the variability not only in the resistance but also in the effect of the load, and is provide measure of the safety related to the failure. Safety in the design is obtained by specifying that the reduced nominal strength of the design structure is less than the effect of factored load acting on the structure, which can be represented by mathematical shape phi Rn more and equal than n multiplied by summation gamma Qi. Rn represent the resistance nominal strength, Qi applied load, and if the factor take into account ductility and other factors. Phi resistance factor or strength reduction factor. Gamma load factor. Phi over gamma is representing factor of safety. We say the mathematical description of allowable stress design: phi over Rn, phi Rn over gamma more and equal than summation of Qi, while in load and resistance factor design, phi Rn greater or equal than n multiplied by gamma Qi. As we mentioned before, load and resistance factor design is more economical design method that it was recommended by manual steel structure manual and take advantage of the full strength of the section. Building codes. Now we're talking about the building code. What is the building code? Building must be designed and constructed according previous of building code, which is a legal document containing requirements related to such things as structural safety, fire safety, plumbing, and accessibility to physical disabled. Building code do not give design procedures, but they do specify the design requirement and constraint that must be satisfied, and this so much important point. Although the engineering is encouraged to investigate the actual loading condition and attempt to determine realistic value, the structure must be able to support the specified minimum loads specified and recommended by existing building code. Design specification. And also, to design steel structure, we should take advantage of the specification of most interested of steel structural design. The specification of most interested to structural steel design are those: American Institute of Steel Construction, AICS. This specification provided for the design of structural steel building and their connections, and this which we use it in this course. We use American Institute of Steel Construction (ATA) in the analysis and design of steel structure and the connection, bolt and welding. We have another design specification, which is American Association of State Highway and Transportation Officials, AASHTO. This specification covers the design of highway, bridge, and related structure. It provides for all structural materials normally used in a bridge, including steel, reinforced concrete, and timber. American Railway Engineering and Maintenance of Way Association, AREMA. The AREMA Manual of Railway Engineering covers the design of railway, bridge, and related structure. American Railway Engineering Association Area and American Iron and Steel Institute did this specification deal with cold form steel. So in this lecture we review a design specification, we review in this structure. So in this lecture we give a review about an introduction about steel structure, the concept requirement in design of steel structure, the material used in steel structure, design philosophy, method of design, building code, and design specification, which is an introduction to the course of steel structure. Thank you for your listening.